All right. So we are going to go ahead and jump straight into writing linked lists. I've went ahead and created a new package and a new class. New project and a new class. But that intro video I think is really good. Just a couple things about the way this will go. I will do my best to draw things for you as we do this. I will typically so I'll be doing this in Google Drawings just simply because that seems to be the easiest way to do this, right? And I'll typically use just a square to represent the node itself and the arrow to represent what it's going to. Typically, a lot of times when we draw linked lists, right, they'll look like this, linked lists, right? They'll typically look something like this where we have separate square for the data and the next, but honestly, you can infer just pointing to the next thing with a simple square. And then I'll just simply connect them with arrows for the most part. And this is because that basically we'll be restructuring this a lot, and you might be wondering why I didn't produce slides beforehand, and it's because I do like to be able to do this as I code, and things might come up as I code. So the node class. So first off, this is a linked list. The reason we can jump straight into this is because of that intro video, but also because we use the exact same things, the exact same operations that we do for a array list. We're going to use get, set, add, and remove. The big difference is the runtime and how we implement them. Circular linked lists are good at linked lists are good at what array lists are bad at, and array lists are good at what linked lists are bad at. So which one you want to use depends on the situation. So let's go ahead and create this. So we've got a linked list, and it's going to be of type E, right? A linked list of something. The other thing is that we need a class to represent the node. So we're going to create something called an inner class. In other words, a class that doesn't exist on its own. It's just a class that's used internally by this outer class. An inner class is just a class. It's a private class that's used by the class it belongs to. So inside of the public class link, we're going to do private static node. Private static class node. The static here in this case means that it can live without needing a linked list. We can create nodes without having made a linked list, as we'll see when we test it. So private static node of E. Other than just pretend it's in a different class, and and that's all you need. So private static class node E. So it is a node of something, and nodes, as you saw in the video, they look like this in terms of code. Private node E next, and private E data. So this is probably now linked lists, just as a side here, this is the section that I find that, not like this specific thing over here. I'm talking like linked list, the module in general, this concept. This is kind of the hurdle for data structures, right? If you can do this and you understand this, then you're probably going to be fine for the rest of the course. Yeah, it doesn't mean you're not going to have to work hard, but you're going to be fine in terms of the amount of work in terms of the work that you're doing, and and all sorts of conceptual, you're going to get that. The big things here that you're going to have to remember is just remember the following words. The memory location on the memory location on the right gets stored in the variable on the left. So you'll need to remember that. And the other thing we need to remember is that basically, how does this node have a node inside of it? It doesn't. It has a reference to another node inside of it. Again, the metaphor of a scavenger hunt really applies here, which is that basically this is the next node in the list. This is the memory location of the guy who comes after me. All right. So we are going to go ahead and program this. So private eData, this is, again, so the node really doesn't have much. It just has two memory locations, where to find this specific data and where to find the next item in the list. That is what the node is. Now, the linked list is built by just connecting these nodes together, right? It is built by basically saying, I'm going to create a node. Oops. It's built by saying, I'm going to create a node, and then I am going to hook it in to this list so that now that this list of 4 items, that was 4 items, now becomes a list of 5 items, right? And it doesn't really matter, again, the arrangement of the way a linked list looks. It can look something like this, right? It can look pretty weird, you know, but that's because these nodes are going to be scattered all over your computer. The advantage of this is that a linked list isn't going to waste memory in the same way as an array list. An array list can waste memory just by having a huge amount of unused space. But that's not to say a linked list doesn't waste memory. A linked list actually technically doesn't waste it. It uses a bit larger overhead of memory. That's to say that basically that for every piece of data, we have to have a node. You have to create a node for it and the memory location of the next item. But that's a discussion for later. But we generally put these together like this. So I'm just going to basically create a shopping list, kind of just on the fly like this. Public static. Let's go ahead, PSVM. And I'm just going to make it out of nodes just to kind of show you how these things work. So I'm going to create a node string is equal to, right? Node string n1 is equal to, I suppose we need a constructor for this, don't we? So let's make a constructor, public. Seems weird to have a public constructor in a private class, but that just means that we can build it. Public node. And this will take in eData, and we'll simply say that this.data is equal to data. Now, your book is going to probably do it very differently no matter what book that is. But the way I do it, I feel, is, and I might be slightly biased here, I feel like the way that I build a linked list is the best way to build a linked list for teaching purposes. I might be slightly biased here. But but here I break it down into some fairly simple stuffs, as you'll see. We'll actually get into the serious programming in the next video but right now I'm just kind of demoing how to connect these nodes. If you feel you've got a kind of a conceptual understanding of it, you go ahead and skip, but to the next video. But otherwise, you probably should stay around here and listen to me. So we're going to create a node of bread. Milk. Eggs. So these are, of course, the, what you typically run out and get when it snows. The perishable items, of course. That's great for a snowstorm. 2 and 3. So the way that we can just hook these nodes together into a single list is that we can go n1 is equal to n1.next is equal to n2. So notice over here, the memory location on the right is getting stored in the variable on the left, n1's .next variable. n2.next is equal to n3. So that means that basically we have enforced this. So let's draw this as it happens. Go ahead and delete these guys. Everybody except this one. So we'll go ahead and create n1. Let's go ahead and let's see, is there a way to center the text? Yep, n1 over here. And might as well use the same font for this as I do for everything else. Control C, Control V. So we've went ahead and we've created 3 nodes. over here. Right? Again, this is why I don't like to make slides for this stuff. I like to be able to do it and mess with it on the fly. So we've got our 3 nodes over here that we've created. Now m1.next is equal to n2. That stores n2's memory location in m1.next. But in terms of how we interpret that in terms of drawing, that means that basically we point this arrow to say m1 and m2 are connected. And likewise, n2.next is equal to n3. We point an arrow like that. Similarly, if I were to do the following, m1.next is equal to n3. All right, so let's go ahead and change that. This would take this arrow and have it point over to here, right? We'd be getting this kind of situation going on, which is possible, but not really what we want our end result of a linked list to be. Really, we want, if we have multiple nodes in the list, they should go from one to another to another. They shouldn't be, multiple things pointing to each other, at least for a linked list. So let's go ahead and go into, this should probably be a much easier thing for us to see. Let's go ahead and close the bookmark bar. Wish I could full screen both of them, but limitations of Windows. All right. So now let's go ahead and write a one last thing over here. Let's go ahead and write a loop that we're going to see a lot. I'm going to create a node called current. Node E current. But notice that I'm not going to give it a memory location. Node string current. Notice I'm not going to give it any. I'm not creating it. I'm just creating a label over here. In fact, M1, N2, and N3 are best actually described as labels, as variables like this. Go ahead, boom, boom. Okay, Control C, Control V. It might be better to think of them like this. Again, this is why I don't make slides. It's easy because I can modify this based on the example that I decide to do. M1, N2, N3. Okay. And now, delete those. Right? It's better to say that basically N1 points to this, N2 points to this, N3 has the memory location of this, N2 has the memory location of this one, N1 has the memory location of this one. Current doesn't have the memory location of anything. Right? These are labels for these nodes which exist in memory. All right. Finally, let's go ahead and say current. Now, if I say current is equal to N1, I will go ahead and be able to draw this and say basically that both M1 and current are aliases of the same node. So now, while current is not equal to null, this is something we'll use. We'll either use, this is something we'll use. We'll also use while current.next is not equal to null. But this is something we'll use a lot. While current is not equal to null. Right? Because remember, it's more to remember this last node is actually does have an arrow, but it's pointing to nothing. Let's go ahead and also go ahead and make it a bit cleaner. So while current is not equal to null. So here we go. And I'm going to go over this again multiple times. We can say that current, so we can system.println current.data, so print out what that data is. And then we can say current is equal to current.next. Whoa, wait a second. What the heck's going on there? Okay. What is this? Does that even work? Bread, milk, eggs. And 1 and 2 and 3. That seems to work. So what's going on there? Well, okay. So this while loop. Okay. So that feel good that basically 2/3 of this automatically makes sense to you. While current is not equal to null. That makes sense. While current is pointing to something. While system.out.println, we do system.out.println current.data. So we print out the data inside of the node. Makes sense there. We don't print out the node itself. That would just be a memory location of that node. We want to print out the actual data that's stored inside of it. Makes sense? Then this last line, current is equal to current.next. Well, this is what I'm getting into about that hurdle. The memory location on the right gets stored on the variable on the left. So current.next. This memory location gets stored. So let's say current is equal to M1. Current is not equal to no, so continue. Print out bread. Current is equal to current.next. Current is this guy. Current.next is this guy. So we take the memory location of current.next and store it in current. So now we do this. Point it there. Okay, so we take this memory location on the right, we take currents.next and store it in current. Which means that basically we take this memory location, store it in the current variable. So now essentially imagine we are taking a finger and we are going ahead and just moving it along. That is what that line is doing. Current is equal to current.next. Now, current is not equal to null. So we print out current.data. So we print out milk. And then we say current.next, store that in current. Take this memory location, store it here. Okay. Now move on to the last one. Print out eggs. Current is equal to current.next. What is this thing's .next? There is no next. So it's null. So while current not equal to null, while current at that point is now going to be equal to null. So we're done. And we printed out something. So we will be using this a lot. But this is basically the basics of how this is going to go together. And it does work.